Dear students, after understanding the concepts about this P block, let us apply these concepts by doing some numericals or some simple problems. The first question, strong reducing behavior of H3PO2 is due to option A, low oxidizing state of phosphorus, option B, presence of two OH groups and one pH bond, option C, presence of one OH group and two pH bond, option D, high electron gain enthalpy of phosphorus. To understand and to attempt this question, we need to know how to write the structure of H3PO2. If you could remember, H3PO2 is phosphinic acid. I write the structure in this format where I have phosphorus, double bond oxygen. I am aware that phosphorus will have 5 bonds, therefore I have written 5 bonds. I have to ensure that 2 oxygen atoms are there. I have already used one, I will use one more. There are 3 hydrogen atoms remaining. I write it as 1, 2 and 3 in this. In this structure, if you happen to observe, it has phosphorus is surrounded by 2 pH bond. It has got one double bond oxygen and one OH group attached to it. Now, greater the number of pH bonds, greater is the reducing feature of the oxyacids of phosphorus. Now, in this H3PO2, I see that there are 2 pH bond, therefore, relatively I would say the reducing nature of this is exclusively because of this pH bond. Therefore, the right answer in the given options that we have A, B, C and D, option C, presence of one OH group and 2 pH bond is the right answer. Therefore, option C is the right answer. Continuing in the same length, by chance if the question is asked, compare the reducing nature of H3PO2 with H3PO3 or with H3PO4. There is another concept here that you need to get up. What is this concept is, I have H3PO3, I write it as phosphorus, double bond oxygen. I am aware that it has got 5 bonds. There are totally 3 oxygen. I have used up 1, remaining 2 I have filled in. There are 3 hydrogen bonds, 3 hydrogen atom. Therefore, I fill it up. Thereby, I get 1 pH bond. Similarly, I have H3PO4. When I write the structure, it is P double bond oxygen, 5 bonds around phosphorus. Total number of oxygen atom 4. I have used 1. Remaining 3. I have allocated all the 3. There are 3 hydrogen atom. Therefore, I write it as POH in all of these. If I happen to observe, H3PO2 has 2 pH bond, while H3PO3 has 1 pH bond. H3PO4 does not have a pH bond. Now, the reducing factor of oxyacids of phosphorus is relatively defined on the number of pH bond. Thereby, I can say H3PO2 is a strong reducing agent, while H3PO3 is next to H3PO2. H3PO4 cannot act as a reducing agent because it doesn't have the pH bond. Hope you have understood this concept.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದೀವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.